Okay, everyone, we're going to do a little Titanic. Did they get what they deserved? That's a different question. And these more recent people that went to visit the Titanic, did they get what they deserved? We can debate that another time. But as you know, we're going to use the GLM function, or maybe you didn't know. So this is different. This is logistic regression. We're going to see if sex was the determinant in survival. We're going to see if passenger class, first, second, or third, was a variable in determining whether or not you survived. So you don't have to be a Marxist to understand the role of class. So let's do it. First, we're going to have to do a few things here. We're going to turn survive, yes or no, to 1 or 0, because you have to. These are binomial dependent variables. A binomial dependent variable is either yes or no. They're mutually exclusive. You have to be one. You cannot be in the middle. So as we know, survive probably is a character. At least I know that. So let's take a look. It is a character. So we're going to make survived into a vector. No package here yet. Oops. All right. And now we're going to recode it. Let's see if I got the deep liar. We got deep liar package already in. So we're going to do Titanic survival. That's the one. And the dollar, and then survived like we did before if you were paying attention to other ones. And then we're going to do the recode. Right. And now we're doing survived. Now, these are attributes. Remember, yes, no are attributes to survived. Survived is the variable. Yes, no is the attributes. And R does not know this unless you put this in a quotation. So, and then I always do 1, yes, no, 0, because it seems to be. Now let's see how it goes. Yes, it works. So now we're going to take a look, see if sex or female or male, that is gender, sex, whatever you want to call it, is a variable. So let's try it. What are we going to call it? What are we going to call it? All right. We're going to call it iceberg, because didn't they hit an iceberg? All right, let's do it. It hit a big iceberg. We're going to do this. All right, so this is GLM. This is generalized linear model. This will recognize this as binomial. It's the same setup with LM, right? So survived is the dependent variable that comes first. Here, tilde. And then sex is the other one. The independent variable, sorry. And then equals Titanic. We're not going to use this one. That one's kind of a boring one. But this one's interesting. You got to do family equals binomial, because that recognizes as a Gaussian binomial, meaning you either have 1 or 0. You're either yes or no, win or lose, etc. So that's very important. So we're going to take a summary of iceberg. Wow. Ba-boom. There it is. And as you can see, sex male, the log odds negative 2.42. That means you are more likely to, and I hate to say it, pass away if you're male. Ooh, that's a big high, negative 17 Z value. The bigger, the more likely it is to be significant, 3 stars, lower than 0.05. You know that we're confident enough to say that there is a strong correlation between gender and survival. And as you can see, the null deviance, this kind of replaces the R squared and residual. So this is basically, as you can see, there's 1 degree of freedom missing. That is degrees of freedom, which is 1 variable, the dependent variable, and then you have the independent variable, so it goes down 1. And the lower here, the better. So the bigger gap between these, and I've seen it pretty significant with only 100 points between the gap. This is 3, 4, 5, 6, 7. Wow. Almost 400. That means that when you use the independent variable to help explain survival, the residual goes down significantly. So the point here is to show that a lower residual relative to the null, you're more likely to have a stronger correlation. And so we're reading these different coefficients. One, this is log odds. It's not the probability, it's log odds. It's called Logistic Regression. -2. And then you have the z-value, which is very high, which gives us a p-value. So it's moving from 0. This means that there is a strong correlation. And then you have significance. I was just going to take it out of that format and put it in the non-scientific one. So you can really see. Wow, 0.00. I can't even count all those zeros. 2, which is extremely significant, meaning you're more likely to die on the Titanic if you were a man. Wow, male chivalry will never die. See, if that was me, I would have just, it would be offensive to allow the women to go first. I believe in equal rights, so I would have just jumped on that boat with Leonardo DiCaprio. Oh, no, didn't he die? So now we want to see, right? We could just scroll back up. Iceberg. And this is classism. Is there classism? We'll just call it, right? Marxism. All right. Marxism. Is Karl Marx still alive? That's what we're going to see. So I'm just changing this from sex to passenger class. Boom. See, it's that easy. Summary of poor Karl Marx. Maybe he was right on this one. You don't have to be a Marxist to say poor people get screwed. So let's take a look. Yes. So the first comes as the base. As we saw before, by the way, I wanted to stress, the reason why female is the base is because female becomes before male. So it's A, B, C, D, E, F, G, H, I, J, K, L, M. Now we get here and we're seeing you are more likely to die, see the negative, if you're a second class, and even more so, because that's a higher negative number, if you're third class. Very high, higher C value here than up there. And as we can see, very significant with the 3 dots. And see, this is still significant even though it's 100. So we could surmise that it seems to be even more so if you're male and female, but then passenger class, definitely the class you have been is true. Now, what do we do if we want to compare? Remember, second class and third class are only being compared to first class. What happens if I want, say, for example, first class to second class to third class? That we can do. We got to make it a factor again because this is a character. We're going to relevel it. That you don't need a package or anything like that, but we're going to relevel it. So let's take the Titanic survival. We're going to relevel passenger class. So let's say third class is the base opposed to first, because first is first, so that's why it's the base. So let's take a look. Relevel, passenger class. And then all you need is the quote, because as the 3 classes, let's see if it works. I'm going to call it Marx. We'll call it, let's call it, so we're not, no bias here. We'll call it, let me see, Smith. Adam Smith. So here we go. We're going to do it with passenger class. Let's see. Boom, boom. Smith is. And yes, it did go to third. So here that's why you see a negative here, as you can see down there. And you are significantly more likely to survive if you're in first. Look at that. Look at that. 10. Wow. That's a big number for the Z value. Bigger, better. Remodel this. Let's take a look. Still about a little more than 100. So what we're seeing here in the Titanic data set, so you learn GLM, this is just another type of regression analysis. It's logistic, the log odds with a binomial logit regression. You could also do probit. That's a little bit different. We won't get into it too much. Let's see if there's a difference. Probit uses a little different algorithm. The link would be, see, you could do link logit or probit. I think logit is the default. So let's go for Smith. See if it changed at all. Now let's take a look at this. Oof. Ooh, let's take a look. It didn't seem to. Oh yeah, it did. The first, second, third, right? So it's that. Let's take a look at the Z value. Oh, it really came down in the first class. 11 here down to 11. Still significant, so nothing too, no big, huge change. Yeah, a little bit, like it's saying now the log odds are opposed to 1.5 is 0.96. It did decrease a little, but it's still, statistically significant. Probit uses a different, it's often used in political science algorithm for logistic regression. They call it logit versus probit. Not to get into detail here, but the goal is you can just change it with the link equals either probit, and you could do logit. It would be the same as not doing anything at all to the binomial because that's the default. So what can we recap here? Number one, we're asking an interesting question. Are you more likely to die on the Titanic? And this is a real data set with all those dead people, unfortunately, between sex and class and whether or not they survive. So we're testing for these two independent variables, class, sex, against a dependent variable which survived, which is binomial. Either you survive or don't survive. So that's a very interesting question. And as we can see, this is a very statistically significant result on all fronts. Regardless of class, you're much more likely to survive if you're in first, then second, then third. What a surprise. And you're more likely to survive if you're female. So this is a really interesting data set. And the inevitable question is, did those people who imploded more recently going down to see the Titanic, did they get what they deserved? I don't know. That's what I always ask the students, and I'll leave that as the last question to ponder on. Take care, everyone.